that we have a tman sample port, a set of neighbors. You may want to have neighbors with ages in here, so feel free to change that. So maybe a peer descriptor instead of an address. And I have a comparator here we've added for comparing peer descriptors based on age. So we can use that to sort lists based on lists of peer descriptors based on their age. So there's two values now for maintaining references in the index. One is what is my last missing entry in the index. Another one is the max entry in the index. I looked at calculating the max index entry using Lucene, but it didn't seem to be that trivial. So I said, okay, it might be easier to maintain that as a variable in the search component. Okay, so the new handlers we have are an index update timeout. So this is a periodic event, which basically says, okay, let's shuffle my changes to my index with my neighbors. Let's look for new missing entries in my index from my neighbors. So it's a periodic event, timed event, saying this is what I will do periodically. Then we have the two messages, one for handling requests from neighbors saying, please give me these missing index entries, and another one for handling responses from neighbors saying, here are some missing index entries. And then finally a handler for getting samples from the tman or the gradient. So I added a routing table. The routing table, actually we can just scroll up higher and see what the routing table is. It's very simple. The routing table is here, and it's a map containing in this case ID is a partition ID and then a list of peers in that particular partition. So if you have 100 partitions, you'll have 100 key value pair entries where maybe the partition IDs will be 1 to 100 or 0 to 99. And for each of those partitions, you'll have a list of peers, references to peers you found in those partitions with their ages, because it makes sense to store their ages and discard old values when you reach the upper bounds on the number of peer entries that you want to maintain in your routing table. Okay, so I removed the code which added a random or a single index entry because we're doing that now up in the scenario. So this change was enforced because we've now changed to using ints for the index ID rather than strings. And yeah, so I added a new reference here for numeric range queries. So I think the last reference here from Stackflow is a bit, let's say, less than helpful, the comments that were in there, and maybe a bit out of date. So numeric range queries seem to work quite well, performance-wise. So let's have a look at, we have our handler now for the periodic events, and what we're doing is we're just getting a random neighbor, finding out all our missing ranges, and then sending a request to our neighbor saying, here's my missing ranges, please send me a response. So I'll jump down to the handler, the response handler. So the response handler you'll have to write yourself. How are you going to merge those missing entries that you received? You'll also have to write the handler for when somebody sends you a request saying, here's my missing entries. In fact, I've helped you along the way here by adding a method called getMissingEntries with a set of ranges, which should add the results to a list of index entries, which you can send back in your response message. So I guess the more, I wouldn't call it challenging, but the little bit of code that I've contributed here, which is probably of most interest, is how to get a set of missing ranges in Lucene. And I have a helper method here called getExistingDocs in range, and you can pass in a start range and end range, and then you need to pass in the index reader and index searcher because that's where you're going to read the values from. Finally, down here you're going to close the index reader when you're done with it. And getDocs in range is this piece of code here. It's basically the numeric range query, and you create a numeric range query. It's using inclusive bounds here. true. So that's going to include the min and max values. What I'm not doing is bounding the amount of results returned. You may want to do that because it may consume too much memory. And yeah, so now we've got a set of docs in a range from our last missing entry to our max missing entry. What is it doing? Okay, so then it's going through each document in turn and pulling out. In this particular one, it's pulling out the index ID for these the existing docs in the range. So what it's basically doing is taking the diff. You can think it as being set difference. We have a set of values that we found in this range, and then we have the set of values. All values in the range are the potential ones that are of interest to us. We have some already. We just take the difference, and they're the ones we're missing. So those ones that are missing, we just add to this res, which is a list of ranges. So you can work your way through the logic of that. If you find any bugs, please fix them and give me a push request. So there's also a helper method here to get any missing index entries within a particular range, and it's doing something similar. It's basically getting all the documents within a range, so from the range lower to the range upper value, and adding the actual index entries then to a list of index entries that you can then return back to the caller of the function. So here's another helper value, quite useful. Get index entries greater than a value. This is often useful for your max index range. So the max index ID you have for a document you've downloaded, you'll say get me all the index entries you have greater than this value. And yeah, so the only final change in this code which is of interest is building the routing table for partitioning. So this is just a simple suggestion for how to do it. You get your cyclone samples periodically, and you just then add them to the to this routing table. So we have our routing table here for each partition, and I get a bunch of neighbors in my sample of event. I loop through them, and then for each neighbor I just find out what partition it is by modding the node's ID with the number of partitions. And for that particular partition ID, I get the list of peer descriptors in that partition that I currently have. If I don't have any, I create a new one. Then I add my node to that partition, that particular list of nodes for that partition. And then I can sort the nodes based on their age, and if I have more nodes than the maximum number of routing entries, I can remove those nodes based on their age. So the oldest nodes I'll remove. Okay, so I guess that summarized the main changes. That's the first commit. I think I made a couple more commits after this, but we can have a quick look through them. So that was the commit from May the 5th. There's a unit test, yeah, for the range. The gradient utility comparator. Let's have a quick look at this. Yeah, I made some changes to the configuration object. So in the gradient, there's a, let's have a look. Yeah, just the configuration object to make it easier to. So yeah, what I did add was I added a parameter called temperature. And temperature is used to do this soft axiom action selection that I've discussed before in class. So rather than select the best neighbor according to the gradient utility comparator function, but to select one with higher probability that's better. So that code is, let me scroll down. That's in here. So here's the tman component where you've implemented the gradient. So here's the code for get softmax address. So you can read your way through it and convince yourself of the correctness of it. There's a reference to the actual algorithm here, but it's basically sorting nodes based on their ID, generating a random number within a range of 0 to 1, and then putting the set of nodes in an array, and then the nodes take up the amount of space in the range relative to their values, and nodes with higher values will, with higher probability, get selected. So that's the, and I think the leader, I think the comparator was here as well, or is it a separate file? Actually, maybe I forgot to check it in that commit, and I put it in the next commit, yes. So here's the comparator. Very simple, and this is the one we discussed in class. And then finally, I just forgot to replace the big int with integer max value in scenario 2. So they're the main changes that I've made. Please feel free to use them, make your own changes, issue merge requests for any fixes or any improvements you can see there. And good luck.